So it says create a frequency table. A survey asked 20 students their favorite season, and we have answers on that here. We've got winter, summer, fall, spring. We've got plenty of them. So I want you can do easily these two because we've already talked about it previously. And I find that I just do hash marks until I can find the actual number, and then I'll put the frequencies over here. So pause the video, do these next to yourself, and then come back and see how you did. So winter, summer, fall, summer, spring, fall, summer, winter, summer, spring, fall, summer, spring, fall, fall, summer, winter, summer, spring, fall, summer, summer is winning big time, and winter. So 4 for winter, 3 for spring, 2, 3, 4, 5, 6, 7, 8 for summer, and 5 for fall. And then the total is 15, 20. There we go. All right, if you didn't get to do this one, please pause the video, do this one, and then come back to see how you did. Here are the numbers of books 15 students read last month, so make sure that you get the frequency for each of these. So 2, 0, 4, 1, 3, 2, 1, 3, 2, 1, 5, 0, 3, 2, 2, 1, 4. All right, and then 3. So 2 for 0, 3 for 1, 4 for 2, 3 for 3, 2 for 4, and 1 for 5. 15. Fantastic. All right, create a bend frequency table. Now we talked about bends. If we've got a bend that's 10 to 14, remember the number includes the 10 and the 14. If we have 15 and 19, it's all numbers between and including 15 and 19. Same thing for 20 to 24, all numbers including 20 and 24 and in between. So again, pause the video, find out how many fit in these bends, and then find your frequency and come back to see how you did. So 12, 18, 15, 19, 11, 16, 13, 17, 14, 12, 10, 20, 16, 15, and 19. 6, 3, 4, 5, 6, 7, 8. There's 15. All right. The next one is something we haven't spoken about. So this is something new. The definition is for relative frequency, and it describes how often a category occurs relative to the total number of observations or data. And it's used to compare categories using percents, decimals, or fractions. And we're going to use all those. So a class survey asked students their favorite type of movie, and these are the results. 12 liked action, 18 comedy, 6 horror, and 9 drama. I need to know the total for this so that I can find the relative frequency. So 17, 5, so the 2, 3, 4. So it looks like 45. All right, to find the fractional version, I'm going to start with fraction, go to decimal, then percents. The fraction, which is still relative frequency, every single one of these that I'm about to do is relative frequency. Some people understand fractions better, some people understand percents better. We did this back in module 2, I believe, so this should be something that you're comfortable with. So the fraction version is 12 for action out of 45. So 12 over 45. Do not reduce. It's not necessary. 18 over 45 for comedy, 6 over 45 for horror, and 9 over 45 for drama. Your total should be 45 over 45 because that's everything. Now to move it to decimal, you just divide. And I'm going to take it to 3 decimal places. when you are done with your decimals, you may or may not have it add up to 1. All right, 1.00. It might be 0.996 because you're rounding every time when you're dividing, and anytime you round, it's going to change the number. So 12 over 45 is 12 divided by 45, which is 0.267. There's my decimal. 18 over 45 is 0.4. 6 over 45 is 0.133. 9 over 45 is 0.2. And from what I was told in class, these do add up to 1, so we just happen to be lucky. All right. When I look at this, though, for myself personally, decimals, I understand them, but I think it's a much better viewing if I have it in a percentage. So I'm going to change my decimal to a percent. And to do that, remember, we just multiply these by 100. And we get 26.7. We get 40, and these are percent, so we need to represent with percent symbols, times 100 is 13.3%, and then times 100 is 20%. Again, it should add up to 100% of the data. Okay, so the decimals add up to 1. The fractions should add up. Fractions are the easiest. It should equal basically 1, 45 over 45, and then your percentages, the closer you can get to 100, that's fantastic. It says, which category is most preferred? When you look at these, which one can you see that the category is most preferred? And I don't mean frequency, I mean relative frequency. So can you see it with the fractions? Can you see it with the decimals? Or is it the percentages? For me, easily the percentages. So which category is preferred? Comedy, which is my preference as well. Does relative frequency change if the class size changes? Well, yeah, because that's going to change your frequency is going to change. Your answers are going to change. So if your class size changes, then how they answer, their frequency is going to change. Not everyone's going to be consistent. So that means your relative frequency will change. Okay, so of course. All right. The next one is creating pie charts. And you've done this in your educational career. So let's just go through this and want to go over it again. The purpose is for relative frequency. You really want to, if you're going to represent relative frequency, you're going to want to use a pie chart. All right. It shows how a whole is divided into categories, and it's best for part to whole relationships or for relative frequency. And comparing proportions. All right. Key idea, each category gets a slice or a proportion or a percent to its relative frequency. And I'm going to show you how to do that. Right here. You're going to find the angle for your pie chart using the relative frequency. All right, so I'm going to bring up the percentages since that's what I want to use. Actually, well, we'll get there. Relative frequency times the 360 degrees, which is the entire circle. All right. Pie chart construction. Use the movie data relative frequencies. So I'm going to bring this. This is 45 if I remember correctly. And then our relative frequency is, I'm going to use, it's probably easiest just to use our decimals for that. So 0.267, 0.4, 0.133, and then 0.2. Why did I use the decimals instead of the percentages? Because anytime you do anything with a number and it's a percent, you have to change it to a decimal, remember, before you can use it. So why would I use percents, then have to change it to a decimal to use it? We've already got the decimals calculated. All right, total is 1. Angle for the pie chart is where you take 0.267 times 360 degrees. And for this, we get 96 degrees. So 0.4 times 360 degrees is equal to 144 degrees. 0.133 times 360 is 48 degrees. And then 0.2 times 360 degrees is 72 degrees. The easiest way to do graphing of a pie chart is just to go into Excel or into Word and do it that way. But what if I asked you just to use the circle I've drawn? Well, you draw a circle, which I've already presented. Use a protractor, or in my case, I'm going to use my best eye, which I'm not an artist, to mark each angle sequentially. And sequentially means in order. So I'm going to start with action, then comedy, then horror, then drama as I do this. I'm also going to label each slice and include the percentages, not the decimals, not the degrees, but the percentages, since that's how most of us see things best. All right, so I'm going to start with action. Action is 96 degrees. So I'm going to start by putting a straight line here as best I can. And then if it was 90 degrees, it would be straight up, but it's not. It's slightly over, and I wished I had something flat. Oh, there we go. My little chewy discount. So that right there feels like maybe a little bit less. That feels like 96 degrees because it's not exactly a right angle, just a smidge over. So there's my best eye. This is going to be a representation of action. And action is 26.7%. All right. The next one is comedy, and it's 144 degrees. Well, if I drew this line straight down, like literally straight down, that would be 180 degrees, and that would be too much. So I need to bring it back some. All right, let's see, how could I do this? Well, if I drew it this way, and this is 26%, or 96 degrees. All right, so let me see what I can do here. I'm going to do it right about there. Okay. And this is, I don't put my degrees, I put comedy, and I put my percentage, which is 40%. Next is we've got horror. That's what I'm going to do next. And then drama. Drama is 20%, and horror is 13.3%. So it needs to be smaller. I'm saying right about there. Right about there. Yeah, that's not too bad. So there's horror and there's drama. You can see comedy is the winner, winner, chicken dinner, then action, then drama, then horror. That is the goal of the pie chart, is to make sure you're representing who's the big dog. You know, what do the percentages look like? Mine are not accurate, but it's definitely, you can see the representation there. Okay, let's go talk about bar graphs. Bar graphs are good for comparing categories. Well, the time you use bar graphs is for frequency. If you use pie charts for relative frequency, you're going to want to use bar graphs for frequency. Not percentages, actual numbers. You can use vertical bars or you can use horizontal bars. Vertical or horizontal bars to represent. And then bars do not touch with bar graphs. Okay, you will learn about some that do touch once you get to the next statistics class. You'll learn about Pareto ones that actually go in order that are kind of cool. I like those a lot. Bar graph, here's the elements: title, labeled axis, even scaling, bars of equal width, categories along the horizontal axis, and frequencies or relative frequencies, which I don't advise, on the vertical axis. All right, for my bar graph sketch, I need to title it. I'm going to call it my movies. And we're going to use our movie information. But I don't want to use my relative frequency. So we need to, it says we want to have our horizontal axis as action, comedy, horror, and drama. So these are going to be my categories. And I'm going to make 2 lines for each category. So from here to here is going to be my action. I'm going to skip a line because they're not supposed to touch. And then I'm going to go from here to here as comedy. Skip another line. And then 2 lines over, I'm going to have horror. Skip a line, and then 2 more for my drama. All right, now for my vertical lines, vertical axis, I want from 0 to 20. Here's the problem. I don't have 20 lines. But if I do 2 for each line, I can make that happen. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. All right. This is my frequency. I need to label my axis. I've labeled my categories for my X. I've labeled frequency for my Y value. And now I just need to know what each is. Action is 12. Comedy is 18. Horror, this is the frequencies that I have from my frequency table, is 6. And drama is 9. So I'm going to represent these on my bar graph. I start with my horizontal line for myself just because I'm not comfortable in drawing straight lines. And for action, I need to come up to 12, draw a horizontal straight line there, and then just drop it straight down to represent that this area is my representation of frequency, how many chose action. The next one is comedy, so I need to go up to 18 right here and just cover these 2 and bring them both straight down. So there is my representation. I'm just having fun right now of my bar representing comedy. Horror has 6, so right here, drop that down. All right, there's my bar for horror. And then drama, we need to go up to 9. So it's going to be in between 8 and 10. So here's 8. I need to go right here and go across. Drop that down. And there is my representation of drama. Okay. Last page. Woot woot. And we're going to talk about a pictogram. All right. A pictogram is a statistical graphic in which the size of the picture is intended to represent the relative frequency or size of the values being represented. Okay, it doesn't have to necessarily be a percentage. It could be the actual size of the values, which is what we're going to talk about now. Here's the example. This pictogram might have produced, the labor union might produce this graph to the right to show the difference between the average manager's salary and the average worker's salary. So looking at this picture, it would be reasonable to guess that the manager's salaries are how many times as large as the worker's salary. The area of the bag looks about how many times larger. So if you look at the worker's salary, how much bigger, how many of these little guys can you get inside this big one? All right, is what we're saying. What are their equivalencies? Well, in class, they said that this one looks 3 to 4 times bigger than this one. So I wrote 3 to 4 times. 3 to 4 times. Okay. However, the manager's salaries are in fact only 2 times as large as the worker's salary, which were reflected in the picture as long as you're seeing that the bag, the manager's bag, is twice as tall. So it has nothing to do with the area. It has to do with looking at that this guy is this tall and this one looks to be twice as big. Okay, that is it. This is what we want you to be cognizant of. If people are showing you this and there's no numbers involved, you need to question it. Okay, if you see a study and you don't know who it's from, or if you don't know how it's sampled, there's different things you need to should bring up red flags. We want you to question everything when you hear numbers, when you see data, when you this is to be a smart voter, to be a smart human. Um, Understanding this information is what's going to help you make better decisions in life, hopefully. So that's it. Let me know if you have any questions, and I'll see you next one.